while for OH we have 1 mole per reaction. So then we subtract both the values, so it'd be, you'd use all 2 moles of NH3, so you'd end up with 0 moles of NH3 at the end. And then you'd subtract 2.5 moles of O2 because you only use half of the actual moles because it's the excess reaction. So you'll end up with 2.5 moles of O2, and 4 moles of NO will become 2 moles because you're only using half of the reactant, so you'll end up with 2 moles. And then OH is the same thing, you start with 6, but it'll become 3 because you're only using half the reactants, so it'll end up as 3. Now the limiting reactant is NH3. We know this because it's the first one to be used up, and excess is O2 because we know it's an excess in the end. We don't use it all up. Now for theoretical and percent yield, we know that the theoretical yield in this equation will be 2 moles of NO if we're using NO as the element we want to, or the molecule that we want to discuss, because that's how much we have calculated if it was in a perfect situation. Now let's say a student completes the same experiment but only ends up with 1.5 moles of NO. What is the percent yield? So if we only end up with 1.5 moles in the experiment, we divide it by the theoretical yield, which is 2, so it'd be 1.5 divided by 2, and then we have to multiply it by 100% or 100 to get 75% yield. So the student got 75% yield of the total amount that they could have gotten.